Hello, hello. Programming. Um, I did not make my resolution super low like I normally do, so hopefully that's not a problem. We'll find out. Today we're going to be making Get It Started tutorials for Footprinter, the repo that kind of drives all the footprint designs for TS Circuit. Pretty cool repo. Basically, we want to get fairly competitive with KiCad, which isn't actually all that competitive. So, it's you're really fighting the forces that be. But KiCad has this library. We built this viewer for all the KiCad library components. So this uses all the KiCad library components. We link back to it and all that. Yeah, we wanna do more. So, to that end, we are going to implement a footprint today, then go over some of the goals of the project. But look how many footprints KiCad has. It's crazy. So all of these can be imported in your projects and used. I hope we're rendering all of these properly. Look at it. It's amazing. It's amazing. In many ways, it would be a much better idea for us to just allow importing the KiCad library. The reason I don't do that is there is not as much rhyme or reason to the names as I would like, which means AI will have a really hard time generating them unless it memorizes them. So that's why we don't do it. But, yeah. So, let's go to the actual repo for Footprinter. I'm going to zoom in on everything because I didn't change the resolution. Might be. So we've got these issues to create footprints. And these are used internally whenever you have a footprint prop on a component. So this little string is called a footprinter string. And a footprinter string will turn into a footprint. We also have a AI tool for generating footprints. So you can say, I don't know, that's a pretty good one actually. QFP component with 24 pins, 0.8 pitch. It generates I think there's a couple of other examples here. BGA components. Sometimes these are missing silk screens, so there's a lot of improvements. But that's how it works. Not too complicated. You can kind of adjust the starting pin, stuff like that. So it is a DSL, domain-specific language, for defining footprints. And we want to be able to make everything. Maybe it could even be a standard. But before it becomes the standard, we need to know that it's comprehensive, because you don't want to introduce trash and then accidentally standardize on trash. I don't know why we even talk about this in the repo. Nobody uses that. Everybody just uses the string form. That's what the AI speaks. So in this video or in this stream, what I'm going to try to do is record the getting started example using this axial thing. So I'll go over the repo structure and how to do it. If for whatever reason you can't find an issue, they're not labeled super well, you can literally click on the mega issue. Maybe this should be pinned. And you can kind of just go through and see like, oh, hey, this one isn't checked off. This one isn't checked off. Or you can go to the KiCad viewer and say, oh, there's no way to create this particular component. And then you can start a discussion. It's kind of like the PM side of it. But we got to get it working. So let's do axial, see how far we get. I think I pulled up, this is a KiCad example of axial. I have no idea what's going on with the silk screen there. That may be a bug on our end, loading in that KiCad footprint. But yeah, let's jump right in. Let's do an axial component. We'll look at the structure of the repo and stuff like that. So footprinter repo, it's open. I'm going to check out. I have an alias on my system to just go to the main branch. So that's why I did main. Just checks out the main branch. I don't really remember how this works, but let's do what we do in any NPM, any project, really, and read the README. Footprinter strings. Let's see if there's a development section. Slop. Slop is a sloppy definition. That might be useful, but we're not going to read that right now. Adding a footprint function. You can add new footprint functions by introducing a new function in the source fn directory. You also need to export it from the footprint function index file. Okay, so we got an index file and a function directory. Okay, after you've written the function, you can introduce a quick test, and then it links to a test. And then to run tests, you run npx ava and path to test. I am surprised this project still uses ava. Is that really true? We still use ava here. All right, that's fine. So we'll use ava for this, but we usually use bun in the new projects. This is a little bit dated. Hey man. Hey complexity. Hey man, been enjoying watching your live VODs. Investing at 54 subs before you become big. Oh, I appreciate that, man. I shouldn't read chat because I'm trying to record this into a dev stream, but I guess I'm gonna waste some of the people's time who's watching. That's a nice thing to say, though. I appreciate that. Okay, so let's go ahead and try implementing axial. An axial is really just a way of saying it's got 2 pins, 2 holes, and they're separated together. So I created a new function. What else did it say in this README? It kind of doesn't tell you much. You know, I'm gonna say that this README is a little bit backwards. I'm not gonna change it, but I'm gonna say it's a little bit backwards. You usually want to start with the test. I find starting with a test gives you so much more direction. So let's start with the test, and it says to open up the SOIC test, or a small outline integrated circuit. And okay, so this is I guess how you do a test. That seems really straightforward to me. So let's go ahead and do this. We're going to implement a new test, new file, axial.test.ts. Paste our stuff there, and then we'll say axial, and then I think a very common configuration will be a pitch of 0.2. So how the footprinter syntax works is it's got lots of abbreviations, and that's because we kind of do a compressed-ish format. So the full version of this is pitch, but we do this kind of compressed format because AI, you can put more into a context when AI is learning from circuits. So we think it's better in the long run. When you do this, you're not going to have 2 SMT pads, so I'm just fixing up this test here. We're going to have plated holes, and there's going to be 2. And we're going to remove that log soup. I don't think that's important anymore. It's kind of old. Snapshot soup. What does this do? Snapshot soup. It looks like it outputs an SVG file. So sometimes we have tests that they take snapshots, they output SVG files, and then those show up in the code reviews. So that way other people know that what you did actually works. And also, if you break anything, the SVG files will change. And so people will know that you changed things. This actually looks super like not right for a snapshot test, because it doesn't actually check the pre-existing file to see if it changed. So a correctly written snapshot test will actually check to see if you broke anything. It'll check the file, and then it'll only update it if you specifically requested to be updated. But that's fine. It's not going to change anything for people developing. It's just kind of an issue for maintainers. The README said to run npx ava and then path to the test. So I'm going to run this. And we can see we get no function found for footprinter. Be sure to specify. And it says got soup. I actually filed this issue somewhere. It says got soup instead of saying got like axial. In this case, the missing function here is axial, not soup. I have no idea why it says soup, not axial. It might be because of this. This is some There's some old stuff here. Should be circuit JSON. Soup is circuit JSON. Soup is like an old name for circuit JSON. So if you see the word soup, it is actually referring to circuit JSON. You know, I'm going to have to post this whole video because this is a little bit of an older repo, and so I'm going to have to explain some terms or something like that. So apologies if you're contributing to this one instead of schematic symbols. This one is definitely not the cleanest, but the ROI on this is really, really high. You're being super helpful if you contribute here, so don't shy away. I hope you do. Hope you win your TS Circuit hat, which we're giving away to people who contribute 5 times. Okay. I want to see what's causing that error, and it might, be informative for us to look at how some of this stuff works. So we're getting FP from get test fixture, and this probably comes from the source code somewhere. Where is FP created? FP, it's literally just exported from source. Okay, export star. We're still looking for that FP. Okay, it's exported at the end here. FP is the same as footprinter. And then I saw down here, footprinter string is equal to string, and string is a function. Okay. I hope that's as messy as that gets, because that was difficult to follow. But string is a function that returns a footprinter object. And I think it looks for our function in like a set of functions somewhere, I guess. I guess this is the set of functions. Or this is just a type. So I guess we have to add our type for axial here. That looks great. AI autocomplete, pretty good. I don't know what D is in this case. I think D would be the size of the plated hole. So you can adjust the size of the plated hole. So sounds good to me. It almost feels like it should be ID and OD, inner diameter and outer diameter. I'm seeing that over here, and that makes a lot of sense to me. So I'm going to do inner diameter, outer diameter for axial. But now where do I implement it? How does this work? Okay, so we've got a proxy object. Looks like a pretty complicated implementation. Ooh, this is interesting. Wherever we see soup, I'm going to try to rewrite it to circuit JSON. Yeah, okay. It looks like some of these are already refactored to circuit JSON, so it's kind of like in the midst of a refactor. And I wonder if there's a type I need to fix for that change too. Yeah, right there. So let's say circuit JSON is equivalent to that. And then let's add the old deprecated message here. Use circuit JSON instead. Okay, I like it. I like it. Little Boy Scout rule in action, improving the code base as we go along. I actually wouldn't recommend doing too many of these little refactors if you're just trying to introduce a function. You might just want to, especially if it's your first PR, just to get in and get out. But I will try to make improvements. Or if you're going in a couple times and you realize something's pretty annoying, it might be time to make improvements. So it looks like everything exported from here automatically becomes kind of part of the footprint function object that we saw. There's this footprint function object. And so everything in here becomes part of that, so we just have to export in from here. By the way, whenever you're doing a contribution like this, it can be pretty helpful to go to the PRs tab, look at the closed PRs, and then try to find something similar. So here somebody introduced SOD123. If I go to this, I get a pretty minimal. We can see, okay, they exported it. They created this function file. And then they wrote this little test. So you can see exactly the steps you need to do. I kind of took the hard route by trying to understand the project, but, it's whatever works for you. We're here to learn. We're here to learn. Okay, so we export from Axial. I don't know if there's anything like Axial, so I'm a little worried about that because none of these are 2-pin components. Axial might be a little bit weird. I don't really know what component to reference. Yeah, it's a little weird. But anyway, this looks like kind of a basic structure, so I'll copy this out for Axial. So we'll go to our function file. I think this is like the meat of the implementation. And you know, a passive component is a 2-pin component, so this might actually work. We could probably hack this to work. It looks like this does a lot of parsing automatically for us, which I really like. I do not hate this. I do not hate this. And it looks like this can do plated holes. Does it support inner diameter, outer diameter? I don't see it. It's got PWPH. I don't know what these mean. PWPH. PWPH. I don't know. I don't know if it's going to clear a plated hole. And then this is my least favorite type of... Oh, it is inner diameter, outer diameter. Looks like. So it's like slightly different. PW times... I don't know. Maybe we shouldn't mess with this. It looks like this is what we need to do, though. We need to return 2 plated holes. So maybe I'll just copy out this part. So we'll say const plated holes equals this. This project uses Zod. So if you're not familiar with Zod, somewhere in here is going to be a Zod definition. Somewhere. I think. Z.object. Okay, maybe not. Okay, usually, I don't know. That's hard to follow. I don't know how some of these are written. But most things will have somewhere a Zod definition, yeah. And in a Zod definition, you're basically just describing how, like how an object needs to be. You can get a type out of it. So you can use it to parse JavaScript objects. So we're going to use a Zod object for our definition for axial here. So we're going to say axial def. And again, most of the time you're going to be able to copy stuff out, so you won't need to use this. But in this case, we can't really copy things out. AI cursor, if you have access to it, it's very helpful for this stuff. We don't have width. We do have pitch. And then 1.27 is a very common default pitch. It's the same as 0.1 inches. So it's very, very common. So we will keep that in there. And inner diameter, outer diameter. So this one I don't know what good defaults would be. Also, I don't think we need this. I think we could just do that. That's a lot cleaner. So inner... I need to find a reference from somewhere else. Maybe that passive guy. But I don't know what the default inner thing is. And I'll show whenever you're like not completely sure about dimensions, you can kind of cheat by going to the KiCad tool and clicking on one of these. And then if you hit D on this tool, it'll actually give you a dimensioning tool. So I can go here and I can see that, actually, I guess it would be from here to here. It's 0.7 millimeters. So the inner diameter is 0.7 millimeters. And then the outer diameter is 1. And so you can kind of get your defaults. But that actually seems a little bit weird to me. Is that right? Maybe that's right. 0.71. I don't know. The pitch on this is kind of weird. The pitch is not our default pitch. So maybe let's see if I can find one with the pitch we're looking for. Oh, wait, 2.54. Oh, I'm sorry. 0.1 inches is 2.54. Okay. If you mess up these numbers, it'll look weird when you get to the snapshot phase. So it's not that big of a deal. Okay. So we found one that was 2.54 pitch. I don't know what the L and the D is in here. I could probably try to figure it out with AI, but I'm just going to leave it be for now. Let's figure out what this is. Yeah, so it's 0.7 again, and then what's this? Okay, so this is pretty standard. Okay, so 0.7 and 1 sounds pretty safe. For the outer diameter, we're going to do 1 millimeter. And then just a small thing, but the order of these matters. So you got to do optional first, I think, with Zod. So you're saying it's optional, and if you don't get it, you do this. I think. Zod is weird. Okay, and we have our axial definition. Copy multi. I'm doing well. We're recording videos for Hacktoberfest contributors. I can create a type for this axial def by doing z.infer or z.output is easier for some people to understand what it is. And if I hover over this, I now get a type for the output there. In this case, for this function, it's actually going to be an axial, or it's actually going to be an input. So the difference between these is now this p is optional, and it also accepts a string. So that's pre-parse. So input versus output, it's basically pre-parsed versus post-parsed before the Zod transforms do anything to it. So we're going to parse out our raw parameters, and I like that name, raw parameters. And then let's pull some of those nice properties out of our parameters. So pitch, ID, and OD, and then we'll pass it in right here to our plated hole function. So hopefully this gives us a nice looking snapshot. And I believe this parameter is outer diameter, yeah. So pretty simple. And then for our circuit JSON, we just say plated holes. In the future, we'll also want to put a reference label. Right now, we do not put reference labels on our footprints, and it's a major pain in the ass. Nobody knows what pin 1 is and pin 2 is, and nobody knows like if that's R1 or R2. So big problem, but we're not fixing that today. Today, we're just getting this minimally working. Okay, so let's run our test file again. And hopefully this time it works. And if you ever get confused, just drop it into AI, or like drop in what you've done to AI, or just run your test. Your test is kind of your source of truth. And you can just, especially once you start getting output, it kind of just helps you to figure out what's going on. Okay, expected number received NaN. Lots of output. Expected number received NaN. And because we put that deprecated comment, soup is crossed out. So now use circuit JSON. I don't want to shake the boat too much, but that probably does the same thing. But I don't want to shake the boat too much yet. We're gonna only debug one thing at a time. By the way, this is a tangent, but it's hot in San Francisco. It's like 85. We're dying over here. In the mission. If you're not in the mission, it's no worries. San Francisco has distinct microclimates, and I'm in the mission, and it's hot. It's hot. A little uncomfortable. I'm sweating. But anywho, what's going on? Expected number. I think what we could do is log the raw parameters. I'm just going to clean up these tabs real quick. We want our test file and our function file, and that's all we need. You know what I'll even do? Nah. I'll keep it. I'll flip between them. Okay, let's log these raw parameters. So we want to know how these are getting to us in our function. I'm going to rerun that test, scroll up. Okay, so we got axial true, function axial, num pins, NaN, P 0.2 inch. Yeah, so for this one, the number of pins is always going to be 2. So we can actually say z.literal 2. Okay, let's take another look. We're still getting NaN for the raw params, but that's fine. That shouldn't be an issue. Invalid literal value expected to. Okay. Annoying. Let's just remove it. We don't even need that prop. Numpins NaN. So that's coming in on the input, but what we'll do... I still kind of want it on the output, so I think what I want to do... I wonder... I don't know if there's a way to do this with Zod, but what I want to say is ignore the input. Z.any. Z.any. And then transform to 2. So no matter what it is, give me 2. And what that'll do, if I log parameters here, that should make it pretty consistently 2. Notice how the 0.2 inch automatically got converted to 5.08. So it automatically gets converted not only to a number, but also to millimeters. So pretty cool. Our test is passing. And if we run git status, we can now see we have this SVG output. If you get an extension, you can view these in VS Code. And that actually looks pretty good. The only thing that's a little weird about this, and I don't know if this is maybe I think this is probably a different bug. Let's see. Let's find something else with a hole, if we can. If there's anything else with a hole, dip 16. I want to see if the holes are supposed to look like that, because sometimes a hole has like a center. It has an inner and an outer part. So I just want to double, triple check holes are actually supposed to look like that. Something's going on with the old IDE here. Yeah, I don't know. This hole looks better. Whoa. Yeah, this is why I don't like the VS Code previews. Yeah, I would, I'll show you how to open it in a browser. I really like if you npm install live server. I'm going to do this in a separate terminal tab. But there's this thing called live server. You can download it, and then you run it as a command line. I just ran live server, this command, after you install it globally. And it gives you a hot, refreshing server for watching stuff. And in this case, we can kind of go to the output directory and click on whatever we want to look at. And this will auto-update as our tests come. So if you look at this hole, it's got this red outer part, and it's got this pink inner part. And that's what I want to see in mine. If I don't see that, I don't think we did it right. So let's find my file now, which is axial. And yeah, I see an outer part, but not an inner part. So let's figure out what's going on. I'm going to run my test again just for sanity purposes. And then I'm going to log the parameters and take a look at them. Make sure everything is coming through. So we got OD1, ID 0.7. I love it. When I click on plated hole, I got pin number, ID, OD. The inner diameter is the hole diameter, and the outer diameter is the outer diameter. I don't know. It kind of looks like we're using this right. Let's log the plated holes. Plated holes just become JSON. It's just circuit JSON. So let's log those, see what's going on. Those look pretty good too. Those look pretty good. Let's go to the dip 16 test. Debug this discrepancy. Dip test. I don't know where it is. There's one test file for all the dips, I guess. I don't know, dip 4. That's not too many pins. So I'm going to run this test. And we will just log the soup. Soup is the old name for circuit JSON. So please don't use this name. It's deprecated now, but it's hard to refactor old code. So, okay, so we logged it. We got silkscreen. Okay, PCB plated hole. And it looks about the same. You got a hole diameter of 1 and outer diameter of 1.2. So to me, looks about the same. I'm not sure why that, why we're not seeing. I'm not sure why we're not seeing it, but maybe it looks like I just changed the footprints on my system. So this could just be in the old, I have an outdated dependency and I'm rewriting these. Yeah, okay. I just have an outdated dependency. So let's see. Because this is an old project, I'm going to first check to see if it uses npm or bun. And it has no lock file. So who knows? Who knows what it uses? Does it really not have a lock file? No, it does. I just have it hidden in my IDE. It has a package lock. So I'm going to run npm I. That'll update my dependencies. And then I am going to just reset the playing field on some of these files. I'm going to do git checkout dash dash, and I am going to reset all of these. I'm going to reset everything I changed in the output directory. Okay, and now I can run get status, and I can see the dip changes are no longer there, and I have that nice red part. So now let's rerun our test. And okay. And then let's go back here. Let's click axial, and there we go. Perfect. So this is not completely done. This should have an outline around it. If you look at the KiCad one, they do like a little line if it's short, but I think they do longer lines if it's bigger, right? So there's still a decent amount of work to do on this one. To add those lines, I'll just show, maybe I'll do like a very basic. So we should be able to add a silkscreen path. I don't know how to add a silkscreen path. Let's look at a dip. We know that they exist in dip because we looked around the SVGs. So how do they do it? We'll just copy them. Silkscreen border. Okay, it looks like we have to define a PCB silkscreen path, and then we put it into the circuit JSON. Okay, so looks a little intimidating at first, but it's not too bad. We just got to use TypeScript to help us. So let's say silkscreen. Yeah, is it a border? Is it really a border in this case? It's more of a, I don't know what you would call it. It's more like a line, because I just want to do the single line. I'm going to be really lazy. And then we'll say this is a PCB silkscreen. Is PCB silkscreen line as an option? Okay, so layer, top. You know what, though? I'm going to do PCB silkscreen path because I think this is more supported. I don't know. AI is going to try to autocomplete everything for me. It did a pretty good job. The only thing I want to change is I want to add outer diameter to this, and then plus, like, I don't know, inner diameter divided by 2. My point in doing that is you'll see, but I want the line to be kind of like away from the holes. So hopefully that comes through. And looks pretty good. Looks pretty good. So now we just do ... plated holes and silkscreen lines. So we're just putting all of that in the circuit JSON. Okay. MPX Ava, run our test. Now let's hop over to our SVG, and now we've got a line in the middle. It's not great, you know? It's not fantastic. Look, you're not winning any awards with this, but you get a contribution. You get a contribution, right? And it's helpful. I actually needed this. I wasn't gonna do this tutorial tonight. I was gonna do other things. All right. I had my whole night planned out of code contributions, and I was forced to do this because I actually needed the axial footprint. So it was the next thing to do, but now it's done. Let's add these files together. And I guess I did this all in one PR. So create axial footprint, add circuit JSON method. We did that, if you remember. Yeah, that's basically it. Check out a branch, axial. If you're on a fork, the flow is slightly different for a fork. It's not that much different, though. I'm going to do GHPR create. Hit enter a bunch. One thing I'll say is you get not only brownie points, but you might even be forced to say fixes and then the issue number. And the reason why is if this isn't in a commit or in the description, a lot of times those issues won't be properly closed. If you put it in like this, it is almost always properly closed. And if it isn't, if you actually go to issue 45, it has a link now. So people can at least see that somebody tried to work on it. So pretty important. The other thing you might have noticed is I didn't run format. If you are a frequent contributor, you don't have to create forks, and so format bot works for you, but unfortunately we can't run format bot on other people's forks because we don't have access to your forks code for pushing. So format bot can only run for us, so you will actually have to run like npm run format or something like that just to format your code with our standard formatter. Usually you just run that command, recommit, whatever, and it's fine. So not too big of a deal. But that's it. If we go to files changed, it's really important to think about how a reviewer is going to look at this. So they're going to read all this code, see what you did, and then they are going to see your SVG, and that is how they evaluate it. So if you don't write this test, it's useless because we have no idea how correct it is. What is this? Little Copilot thing? Explain. All right. All right. So yeah, these SVGs are super important. But that's it. Good luck contributing to Footprinter. Let's see. Yeah, that's about it. And that was also the main point of my live stream. So I will probably conclude the stream. This was a real single purpose stream. Thank you for tuning in. I'm going to be doing a lot of streams through Hacktober. All of the streams are posted. They all have AI descriptions on DevStream. On our blog, blog.tscircuit.com/devstreams or something like that. Just go to the blog. You can see all of them, and there's a lot of other guides for contributing to other repos. So definitely hop in there if you're not in there. Also, our Discord. We're starting to do AI podcasts where we look at contributors' work in the AI podcast. So if you want to be in the podcast, you just have to do some contribution, and it shows up in our contribution tracker, and you can see, you can listen to yourself being talked about. We all love to hear what we've done.